China is no longer content with building a single flagship project. It is building an entire empire of steel, a gigantic ecosystem of megaprojects that fit together like the gears of a colossal machine. Fully automated factories weave steel like fabric. Floating wind farms stretch to the horizon. Shipyards are so enormous they look like entire autonomous cities. While much of the world hesitates, China charges ahead. It builds faster, larger, and smarter than almost anyone else, including the United States. Number 1. The Shenzhen Zhongshan Bridge. Tunnel where bridges meet the sea. There are bridges. And then there is the Shenzhen-Zhongshan Link, a project so ambitious that it literally dives beneath the waves. Inaugurated in June 2024, this $20 billion megastructure connects Shenzhen and Zhongshan across the Pearl River Delta, cutting travel time from 2 long hours to just 30 calm minutes. What was once a tiring car journey now feels like a simple stroll on your balcony. At the heart of this engineering marvel is a 6.4-kilometer, 8-lane underwater tunnel, built with astonishing speed and precision. The world's widest underwater tunnel was bored in only 110 days, thanks to a gigantic tunnel boring machine with a diameter of 17 meters. Imagine a mechanical earthworm on steroids, chewing through the seabed with millimeter precision. More than 500 tunnel segments were assembled like pieces of a puzzle to form a watertight and earthquake-resistant structure, designed to withstand ocean pressure. The engineers did not just build big, they built smart. Automated monitoring systems and China's Beidou satellite navigation now keep constant watch over the tunnel, ensuring smooth traffic and rapid response in case of emergency. And this record-breaking tunnel did not sacrifice the environment. Instead of using loud and destructive explosions, engineers opted for precise mechanical excavation, protecting the habitat of the endangered Chinese white dolphin. A mega project. Yes, but with an ecological conscience. The Shenzhen-Zhongshan Link did not just break 10 world records. It rewrote the rules for combined bridge-tunnel infrastructure, a perfect alliance of scale, speed, and precision. It symbolizes China's determination to push boundaries and connect its cities like never before. Number 2. The Zhangbei Flexible HVDC Grid, the Green Energy Highway. Imagine a highway, except instead of cars, it carries clean energy. That is exactly what the Zhangbei Flexible DC Grid is. A super green highway that delivers massive amounts of wind power straight into the hungry electrical network of Beijing. This is not a normal power line. Zhangbei is the world's first 4-terminal HVDC grid using voltage source converters, a true technological milestone. Built and operated by the State Grid Corporation of China, the system links Zhangbei, Kangbao, Fengning, and Beijing in a circular, flexible network, like a sharing ring of clean energy. Construction began in 2018, and by mid-2020, the grid hummed to life in successful trials. Its mission: to transmit up to 4.5 gigawatts of clean energy and help power the Beijing 2022 Winter Olympics with green electricity. But the real story is about vision, not just voltage. The Zhangbei project can deliver around 14.1 terawatt-hours of clean energy every year, reducing carbon dioxide emissions by 12.8 million tons. Coupled with pumped storage hydropower stations, it smooths the unpredictable ups and downs of the wind, guaranteeing a stable and reliable power supply. This grid does more than keep the lights on. It powers a cleaner future and proves that flexibility can be a strength when it comes to renewable energy. Number 3. Deep Sea. Number 1. China's giant offshore energy fortress. If you sail about 150 kilometers off the coast of Hainan Island, you will not just see a calm blue sea. Hidden beneath the surface lies one of China's boldest engineering achievements. Deep Sea No. 1 is not just a gas field. It is a floating fortress of steel and innovation, extracting clean energy from more than 1,500 meters below the surface of the South China Sea. Launched by the China National Offshore Oil Corporation, this project is much more than a technological feat. It is a symbol of how far China has pushed into ultra-deepwater operations. Officially operational since 2021, Deep-Sea No. 1 produces around 3 billion cubic meters of natural gas per year, enough to cover a significant part of the energy needs of the Greater Bay Area around Guangdong, Hong Kong, and Macau. That means millions of homes heated, factories powered, and lights shining thanks to a structure built to withstand the ocean's most violent moods. The true star is the energy platform itself. Shanghai Yihao, the world's first 10,000-ton semi-submersible production and storage unit. Imagine something as long as 2 football fields and as tall as a 40-story skyscraper, yet floating stably in the open sea. Built in Shandong province, this steel giant rests on an innovative truss structure, lighter than traditional designs, but far more complex to design and balance. Engineers had to calculate every force, every weld, every shift in mass to ensure it could resist waves and time. Under the deck are huge buoyancy tanks and 4 massive columns that keep the platform stable even in extreme conditions. This is not just an oil and gas platform. It is a fortress designed to thrive where the sea is most hostile, and the story is just beginning. The second project phase, scheduled for completion around the end of 2025, will increase total production to about 5 billion cubic meters per year, tapping reserves estimated at more than 150 billion cubic meters. Projects like this strengthen China's energy security while pushing the limits of offshore technology, acting as an energy bridge between deep waters and some of the country's most dynamic cities. Number 4. Xiong'an New Area, China's city of the future. About 100 kilometers south of Beijing, a new city is quietly rising. But this is not just another concrete jungle. It is Xiong'an New Area, an audacious experiment to build China's city of the future. Announced in 2017 by President Xi Jinping, the project is designed not only to ease the pressure on the overcrowded capital, but also to completely rethink 21st century urban life. Unlike most cities born from chaos and traffic jams, Xiong'an is being built with intention. The city has a digital twin, a complete virtual replica that allows real-time management of everything from traffic to energy consumption. Think of it as the city's super brain, constantly analyzing and optimizing its breathing, movement, and growth. 25 government agencies oversee its development today, managing sectors such as education, health, technology, and industry. The city will also host relocated institutions, including universities and state-owned enterprises, to relieve Beijing while boosting growth in the larger Beijing-Tianjin-Hebei region. Xiong'an is not just smart, it is also green. Urban construction is limited to about 30% of the area. Geothermal energy supports heating, and ecological zones are woven directly into the master plan. By 2035, the city is expected to host around 5 million residents living in an environment managed by artificial intelligence, powered by renewables and designed for people, not just for cars. Xiong'an is China showing the world its vision for the cities of tomorrow. Number 5. The HTR-PM nuclear reactor at Shidao Bay. A nuclear revolution. Nuclear energy is not new, but what is happening at Shidao Bay changes the story. On the northeastern coast of Shandong province stands the HTR-PM, the world's first commercial fourth-generation high-temperature gas-cooled modular reactor. Instead of relying on huge, water-cooled reactors of the past, this elegant modular system is smaller, smarter, and surprisingly flexible. At the heart of the site, the Shidao Bay Unit 1 uses helium as a coolant, graphite as a moderator, and tiny fuel pebbles coated with protective layers of carbon and silicon carbide. The design focuses not only on performance, but also on safety. In an emergency, the reactor can cool itself naturally, without external intervention. No frantic button pressing, no need for giant water tanks. Physics takes over. The plant does more than generate electricity. It also produces high-temperature steam used to heat thousands of homes in winter, replacing large amounts of coal and reducing emissions by thousands of tons per year. Clean energy goes straight from the plant to people's radiators. Connected to the grid in 2021 and fully commercial since late 2023, this project marks a major leap in nuclear innovation. 2 reactor modules feed a single 210-megawatt turbine, and China is already planning a larger HTRPM 600 version with 6 reactors driving a single turbine. By embracing pebble bed technology, China is not just producing clean energy. It is opening a new era of safer, more compact, and more intelligent nuclear power. Number 6. Tiangong Space Station, China's home in orbit. If Xiang'an is China's city of the future on Earth, Tiangong is its outpost among the stars, floating hundreds of kilometers above our planet. Tiangong, which means heavenly palace, is not just a satellite. It is China's own space station. After being excluded from the International Space Station program, Beijing decided to build its own and did it step by step. It started with Tiangong 1-inch 2011, then Tiangong 2 inches 2016, 2 experimental stations that quietly paved the way for something much bigger. The real leap came on the 29th of April, 2021, when Tianhe, the core module, was launched into orbit. Soon after, cargo ships and crewed missions followed, turning a steel shell into a real home for astronauts. Today, Tiangong consists of 3 modules: Tianhe, Wentian, and Mengtian. Completed in 2022, it generally hosts 3 astronauts for 6-month stays and can accommodate 6 during crew rotations. It is smaller than the ISS, but packed with advanced technology and ambition. Inside, astronauts conduct experiments in life sciences, materials science, and astronomy, preparing for even more distant missions. Tiangong is a stepping stone toward the Moon, Mars, and beyond. It is not just a scientific project. It is a statement, a permanent Chinese presence in space. Number 7. Concrete megastructures and global collaboration. In the world of megaprojects, concrete is not just a building material. It is the silent muscle that keeps nations standing. China treats it the way a conductor treats sound, with precision, ambition, and astonishing scale. We are talking about construction sites where millions of cubic meters of concrete are poured in weeks, not in years. What might take other countries 5 years can be done in a single construction phase in China. Part of this dynamic comes from strategic collaboration. Take Sasir, a Spanish giant recognized for its engineering expertise. Its role in international projects, like the expansion of the Panama Canal, shows how concrete can become a bridge between nations, not just between riverbanks. That single project required more than 4 million cubic meters of concrete and reshaped global shipping routes. Number 8. Baihetan Hydropower Station, the colossus of clean energy. If Zhongbei is the green energy highway, Baihetan is the roaring engine at the heart of China's clean energy revolution. Rising from the Jinsha River, a major tributary of the mighty Yangtze, this hydropower giant does not just hum, it roars. With an installed capacity of 16 gigawatts, Baihetan is the second largest hydropower station in the world, just behind the Three Gorges Dam. It can power tens of millions of homes, equivalent to the electricity consumption of an entire small country, all from a single massive dam. The dam itself rises nearly 300 meters high, a concrete wall standing like a modern Great Wall against the river. But it is not only about brute force, it is also about precision. Baihetan is equipped with advanced flood control systems, sediment management, and safety mechanisms designed to last for decades. Environmental protection was also part of the mission. Engineers implemented measures to safeguard aquatic ecosystems, proving that producing clean energy does not always mean ecological disaster. Strategically, Baihetan changes the game. It cuts China's reliance on coal and prevents the emission of millions of tons of carbon dioxide each year. This is hydropower on a titanic scale, a blend of ambition, engineering, and ecological vision. Number 9. The distributed thrust arch bridge. In the world of megaprojects, some solutions are not just strong, they are elegant. The distributed thrust arch bridge is one of them, an engineering solution that looks almost poetic, stretching across valleys like a curved steel arrow. The beauty of an arch bridge is not just in its shape, but in how it handles force. An arch channels loads along its curve, pushing them down and outward so the load transfers perfectly into the supports. Every piece of steel and concrete fits together like a perfectly tuned orchestra, allowing the structure to carry enormous weight while looking light and graceful. Modern China has taken this ancient concept, first mastered by the Romans, and pushed it to a whole new level. With projects like the Third Pingnan Bridge and the Kaohamen Bridge, China now holds several world records for the largest and most complex arch bridges ever built. While other countries can spend years debating plans, China moves from drawing to construction at lightning speed. These bridges are not just transport routes, they are symbols of power, standing silently above rivers and valleys, blending technology and nature, strength and elegance. China does not build against the land. It builds with it, shaping steel and concrete to follow the landscape instead of erasing it. Number 10. Steel reinforcement, the invisible skeleton. If bridges and skyscrapers are the muscles of a nation, then rebar is the skeleton. Silent, hidden, but absolutely essential. Concrete often gets the glory for being strong, but the truth is simple. Concrete alone resists compression very well and tension very badly. Without reinforcement, every giant bridge or skyscraper would be a fragile colossus with weak knees. Reinforcing bars, or rebar, are steel rods designed to give concrete the tensile strength it does not naturally have. These rods are cut, bent, and woven into complex frameworks before a single drop of concrete is poured. Once combined, steel and concrete behave like bones and muscles. The concrete takes the pressure. The steel resists stretching and bending. Here, China again changes the rules. While many countries still rely heavily on slow, manual rebar work, China uses automated assembly lines that look more like car factories. Machines cut and bend the bars with perfect precision. Robotic arms weave meshes. AI-driven systems map out layouts in real time. What might take days elsewhere can be done in hours in China. This level of synchronization is not just about speed. It is about structural reliability. Every bar placed exactly where it should be means stronger structures, fewer cracks, and a lower risk of failure. Number 11. Container cranes and the power of lifting. When a container ship the size of a small city enters a port, a simple forklift will not do. What you need is a giant container crane, the true muscle of global trade. These titanic machines can lift hundreds of tons in a single movement, making containers dance through the air in a ballet of steel and precision. Technologies like ship-to-shore gantry cranes are the backbone of ports, shipyards, and vast industrial terminals worldwide. Their job is not just about brute force, it is about speed, safety, and coordination. Automated control systems guide the lift, stacking and moving cargo with surgical accuracy, turning days of work into just a few hours. Nowhere is this mastery more visible than in China's megaports, especially Shanghai, one of the busiest ports on Earth. China's port cranes are among the largest in the world, capable of lifting loads so heavy that older cranes would creak in protest. And they are not just powerful, they are smart. AI-assisted control systems allow multiple cranes to work in perfect harmony, moving containers like puzzle pieces on a global chessboard. This is not just industrial strength. It is a silent revolution in how the world moves its goods, faster, cleaner, and more efficiently. Now, imagine that scale multiplied across China's high-speed rail lines, megadams, and colossal bridges. Each pore and each beam are part of a precise balance between local speed and global expertise. European companies bring precision, Chinese teams bring sheer power and rapid execution. Together, they redefine how the world builds the future. Number 12. The Holbach Viaduct and Modular Building. In many countries, large infrastructure starts with endless plans, committees, and years of paperwork. In China, it often starts with prefabrication workshops and launching girders. That is why bridges and viaducts rise not in decades, but sometimes in just a few months. Take the Holbach Viaduct as a perfect example of modern viaduct construction. About 2,400 meters long and 8.6 meters wide, this structure is not just an engineering achievement. It is a demonstration of precision, durability, and vision. Designed to combine functionality and aesthetics, the viaduct does more than connect distant points. It crosses difficult terrain with elegance and efficiency. Its construction relies on advanced techniques that guarantee stability, low maintenance, and remarkable longevity. Instead of building everything on site, 979 modular segments were prefabricated nearby, each designed to fit perfectly like pieces of a puzzle. This is where the 600-ton launching girder comes in, a gigantic steel arm that slides each segment into position with surgical precision. No endless scaffolding, no years lost in complex logistics. Segment by segment, the viaduct stretches forward like a concrete caterpillar climbing into the sky. While some countries spend years just approving a project, this modular approach cuts time and costs dramatically. Prefabrication ensures optimal quality control, while the launching girder reduces dangerous manual handling, improving both efficiency and safety. This is not just a bridge, it is a statement. Speed does not have to mean carelessness. It can also mean intelligent engineering, careful planning, and flawless execution. Number 13. Cleaning solar panels, the hidden battle for efficiency. A solar farm might look peaceful, endless rows of panels glistening under the sun like mirrors on a quiet lake. But behind that shine lies a constant battle against a stubborn enemy, dust. Even a thin layer of dust can cut energy output by up to 30%, turning a multi-billion-dollar solar project into a field of underperforming glass. In China, where some of the largest solar farms in the world stretch across deserts and high plateaus, cleaning is not just maintenance, it is strategy. Instead of relying on slow, large crews of workers, China deploys cleaning robots that glide over the panels like silent sentinels. These machines use soft brushes, compressed air, or dry cleaning systems to remove dust without scratching the surface. And they are fast. What would take human workers days can be completed in a single night, keeping the panels close to their maximum output. Integrated sensors detect levels of soiling and automatically schedule cleaning cycles, turning a manual chore into a smooth, AI-managed operation. It is not about aesthetics. It is about squeezing every last watt out of the sun. The cleaner the panels, the more energy flows into China's renewable grid, powering homes, factories, and the tunnels it drills through mountains. In the global race for energy independence, China is proving that even the smallest details can fuel a revolution. Number 14. The making of jet engines, hearts of steel and fire. If helicopters and aircraft are giants of the sky, then jet engines are their beating hearts. Raw power wrapped in layers of mechanical precision. The process begins in blazing foundries, where superalloys based on nickel are melted and poured into meticulously designed molds. These are not ordinary metals. They are engineered to survive temperatures that would melt most materials in seconds. Once cooled, the metal is forged into massive compressor discs, the backbone of the engine. But the true art lies in the blades. Machining at micron-level precision ensures each turbine blade is not just identical, but aerodynamically perfect. The smallest defect, invisible to the naked eye, can cause catastrophic failure at tens of thousands of revolutions per minute. These blades must endure temperatures exceeding 1,500 degrees Celsius. That is why special coatings and heat treatments are applied, acting like armor against the heat. Then comes the combustion chamber, where compressed air is ignited and expelled at high speed, producing enormous thrust. Once assembled, the engine is strapped onto a test bench and pushed to its absolute limits, roaring like a contained thunderstorm. For years, the United States and a few other players dominated this field. But now, China's programs and rapidly growing aerospace industry are changing the equation, creating engines designed to power the country according to its own standards and ambitions. Number 15. Floating wind power and the Atlantic testbed. Far off the coast of Viana do Castelo in Portugal, something extraordinary floats on the Atlantic. It is not a ship and not an oil rig, but a floating wind farm, Windfloat Atlantic. With a capacity of 25 megawatts and elegant semi-submersible platforms, it is a first for continental Europe, proving that offshore wind power does not have to be anchored to the seabed to be powerful. What makes this even more interesting is that, while this project sits in European waters, China is leading the race in floating wind technology. Along its coasts, floating offshore wind farms stretch like a necklace of steel and energy. China is now exporting its know-how abroad. Using advanced platform designs, more economical construction methods, and a finely tuned supply chain, China is not just building at home. It is quietly helping shape the future of energy in other nations' waters. Offshore wind is no longer just a local solution. It is a global strategy, and China's involvement is not only about competing. It is about setting the pace for a new era of renewable energy. Number 16. Forging hydroelectric turbines, the iron hearts of rivers. Forging a hydro turbine is like building a steel heart powerful enough to turn the unstoppable force of a river into clean, almost endless energy. It starts in roaring foundries, where enormous blocks of specially alloyed steel are melted and cast into huge molds. After a long and careful cooling process, what was once a glowing mass begins its transformation into one of the most important machines on the planet. Then comes precision. Giant multi-axis CNC machines carve the steel with millimeter accuracy, sculpting elegant turbine blades that slice through water like a knife through silk. Their curves are no accident. They are designed to withstand crushing pressure while capturing as much energy as possible from the flow. This is not a simple workshop. It is where craftsmanship meets cutting-edge technology. Next, every weld, every curve, every blade angle is inspected, scanned, and measured. Non-destructive ultrasonic tests hunt for hidden flaws, ensuring these giants can operate for decades without failure. China, home to the Three Gorges Dam, dominates the global hydropower turbine sector, building turbine assemblies as large as houses to feed its renewable grid. Number 17. Pumped storage, the silent battery. When a city's lights switch on at peak hours, somewhere far away silent reservoirs are already preparing to respond. This is the magic of pumped storage, a technology that turns still water into unstoppable energy. Projects in Europe, like large Swiss plants, show how this works. When energy is cheap and abundant, often at night or during strong wind or sun, water is pumped from a lower reservoir to a higher one. Then, when demand surges, that same water thunders back down through turbines, driving generators and lighting entire regions. This simple but brilliant system allows countries to stabilize their grids with remarkable precision, and China has taken it to the next level. As a global leader in renewables, it is now building the largest fleet of pumped storage plants on Earth, ensuring its network remains stable when the wind drops or the clouds roll in. Unlike batteries, which degrade over time, pumped storage can last for decades, delivering clean energy over and over again. It is the silent backbone behind shining solar panels and spinning wind turbines, a reminder that the future of energy depends not only on production, but also on intelligent storage. Number 18. The birth of helicopters, giants of the sky. Here is how giants of the sky are born, not from a single spark, but from thousands of precise engineering steps. It begins with ultra-strong metal alloys forged and shaped under enormous hydraulic presses. Every curve of the fuselage, every joint, has to resist both gravity and turbulence. Once the structure takes shape, the real magic begins. The engine and the transmission system are installed, the beating heart of the helicopter. Thousands of precisely machined parts come together to create a machine capable of taking off vertically, hovering in midair, and landing where an airplane would never dare to go. The crown jewel is the rotor. These long, slender blades must be perfectly balanced. A tiny millimeter of error, and the entire machine could tear itself apart in vibration. After assembly, every helicopter undergoes rigorous flight tests. Pilots and engineers push it to its limits. Only after it passes tests of vibration, turbulence, and stability does it truly earn its wings. Today, China's aerospace industry is booming, producing helicopters not only for defense, but also for commercial missions and rescue operations. Its growing fleet includes advanced military and civilian aircraft, showcasing a blend of ambition, technology, and experience. Number 19. The making of giant dump trucks. They rumble through mines and megasites like rolling steel fortresses. Giant dump trucks are not ordinary vehicles. They are the beating heart of megaprojects, capable of hauling mountains of earth and rock. Their creation begins with thick, heavy steel plates bent and pressed into a robust chassis designed to withstand brutal conditions. This frame must be absolutely solid and perfectly balanced, because these monsters move with hundreds of tons on their backs. Next comes the heart of the machine. Massive engines, delivering thousands of horsepower, combined with powerful hydraulic systems that allow the truck to tip and unload its colossal cargo as if it were nothing. Then there are the wheels, each one as tall as a small car, built to crush the roughest terrain without flinching. Assembly is only half the story. These trucks face punishing load tests. They climb steep slopes, cross mud pits, and endure stresses that would tear normal machines apart. Only after passing all these trials do they earn their place on the world's largest dams, bridges, highways, and mines. China's infrastructure boom has turned these trucks into symbols of industrial might. Models like the XDE 440 from XCMG can haul more than 400 tons in a single trip, longer than a house, and more powerful than a locomotive. They work day and night, fueling an expansion the world can no longer ignore. Number 20. Building giant cranes, the empire builders. They do not fly, but they move mountains of steel. Giant cranes are the silent titans behind modern skylines and megaprojects around the world. Their story does not start in the sky, but on factory floors, where high-strength steel is forged and pressed into massive beams. Every curve, every joint, every weld is planned down to the millimeter. Because one day these machines will lift loads that defy imagination. Once the main structure is complete, hydraulic systems and motors are installed with surgical precision. These are the heart and muscles of the crane, controlling its powerful and carefully measured movements. The mechanical arms, designed to endure extreme stresses, are tested to ensure they will not bend even when lifting weights heavier than a blue whale. Assembly feels like a gigantic steel puzzle. The tower, the jib, and the counterweights fit together to balance raw strength with stability. Before leaving the factory, each crane undergoes intense load testing and precise electronic calibration to ensure it can face the harshest conditions. What is impressive is that China does not build these cranes only for itself. It is one of the world's major exporters of heavy machinery, supplying ports, shipyards, and megacities from Africa to Europe. From the XCMG XGC 88000, the most powerful crawler crane in the world, to the XCA 2600, a mobile giant capable of lifting wind turbine components to staggering heights, China's crane fleet embodies both force and precision. In ports, ZPMC cranes rule quietly over global trade, while other Chinese manufacturers power the rise of offshore wind. These titanic machines are not just tools, they are empire builders, transforming steel and cables into skyscrapers, energy hubs, and megaprojects that redraw the world's horizons. From underwater tunnels to sky-high cranes, from nuclear reactors to floating wind farms, China's megaprojects are reshaping not just its own landscape, but the way the entire world thinks about engineering, speed, and scale. Some see this as inspiring, others see it as a challenge. But one thing is certain, these projects are not just lines on a blueprint. They are the steel, concrete, and energy that will define the 21st century. If you enjoyed this journey through the world of megaprojects, don't forget to like the video, subscribe, and turn on notifications so you don't miss the next deep dive into the infrastructures that are changing our planet.